All right, line A1, learning task number 2. We're going to take a look at the relationship between the sides and angles of right-angle triangles. And once again, we're going to focus on the right-angle triangles because so much of our calculations are going to be based around the right-angle triangles. Later on, we're going to deal with impedances. We're going to go and deal with power and power factor and watts and bars and VA and all the rest of that type of stuff that is going to involve right-angle triangles. We wouldn't be going through this if it was not critical to what we were going to be covering off later on. First of all, the very first thing that I want to talk about is the fact that we are going to be using ratios. Really, all that we are going to go and do for all of our trig functions, which is going to go and be my sine, my cosine, my tangent, my cotangent, cosine, inverse sine, all the rest of those are all going to just be ratios. Ratios just mean a comparison of one side over to the other side. We're going to go and start by doing some labeling of our triangles once again. Same as what we did before. We labeled the hypotenuse before. Now what we need to do is we just need to go and label everything from our viewpoint. What we need to go and do is stand right over here at this angle theta. And standing at angle theta, we then look across the triangle. We're going to label that side as being opposite. On the same side or adjacent to us, we're going to call that side the adjacent over here. We're not going to go and use all of these A, B's, and C's because A, B's, and C's are going to be arbitrary based upon where we're standing. If we were going to be standing right over here, our perspective would be that A would be adjacent and B would be opposite, whereas if we were to go and stand on this side over here, we would say that B would be adjacent and A would be opposite. That's why we're not using the A, B, and C from Pythagoras. What we're going to do is we're just going to go into deal with the terms opposite, adjacent, and hypotenuse. Usually we just go and short form those things down into their first letter. HOA, which also, by the way, stands for a handoff auto, which is a type of switch we use in electrical. But that's not part of this over here. Okay, when we go into a triangle, we have to be able to go and analyze. They give you a little exercise over here. Pause the video, go through this one, figure out based upon where the angle is, what each of your sides are going to go and be. They show you angle phi, they show you angle theta, they show you angle beta, and they show you angle alpha. Any one of these can be used to identify an angle. Just always stand yourself into that corner, whichever the angle is going to go and be, and then from that corner, you're going to go and look for opposite, you're going to look for adjacent, you're going to go and look for hypotenuse, etc. Pause, go. All right. The ratios of our sides are going to go and stay constant. And really this is just going to go and tell us about the angular degrees that we are going to go and have. There's going to be this super common triangle that we're going to see again and again and again, which is going to be this 3, 4, 5 triangle. And a 3, 4, 5 triangle simply has got a hypotenuse of 5 and a one side that's going to be 4, the other side that's going to be 3. It could either be, a shorter and wider triangle the way they have it here, or they could draw it with, this side being the 5, this side being the 4, and this side with being the 3. Either way would work, we would still have the same 3, 4, 5. What we find out is that if we have got the same ratio or the same angular degrees that I'm going to go and have, I'm going to end up with the same ratios that I would go and have. For example, if I were to go and take my opposite over top of my hypotenuse, for this one, my opposite, looking across here, would be 3 over top of my hypotenuse of 5, which would work out, if you take 3 divided by 5, it works out, it becomes 0.6. And if I were to go here and do the same opposite, which is going to be 6, over top of hypotenuse, which is going to be 10, I would see that 6 out of 10 is also going to go and give me a ratio of 0.6. What this would tell me is that I'm going to have a constant ratio, no matter the size of my triangle. If it's got the same angular degrees, right? This one over here is 90, this one over here is 90, this one's 37, this one's 37. This one, by default, then would have to be 53, so they all add up to become 180. Same with this one over here. This is just going to give me a constant ratio, and that ratio, we then go and give it a set name. In this case, the name of the ratio that is for the opposite side over top of our hypotenuse, we would call that the sine of the angle. So I could go and say that the sine of this angle, which is 37 degrees over here, the sine of 37 degrees is going to be 0.6. And it just stays as a constant after that. We've got a whole list of these. Sine is going to be my opposite over hypotenuse. It's going to be my ratio of just the measurements. Cosine is going to go and be my adjacent over top of my hypotenuse like that. And then my tangent is going to go and be my opposite over top of my adjacent. As long as we have got at least 2 measurements inside of a triangle, we will be able to go and find all the rest of them, provided it's a right angle triangle. I could go with an angle and then an opposite or an adjacent or anything like that. You should remember from back in grade school something about SOHCAHTOA. And it's just our short way of trying to remember which of these are going to be the relationship for sine, the relationship for cosine, and for tangent. So, sine is opposite over hypotenuse. Cosine is adjacent over top of hypotenuse. Tangent is opposite over top of adjacent. Memorize that. You do need to have that down. It's just going to become base knowledge that we're going to rely on you having from this point forward. They give us then a triangle to go through a bunch of different examples over here. And they ask us to go and find the sine of the angle, the cosine of the angle, and the tangent. First of all, if you take a look at this, you should recognize it as being a 3, 4, 5 triangle. If we take a look at our sine is going to be based upon us standing in the angle over here. We're going to look across. It's going to be the opposite over my hypotenuse. So I would be able to say that the sine of this would be 0.6. If I were to go and take a look at my cosine, it's going to be my adjacent over top of my hypotenuse, and I would say that my cosine would be 0.8. And if I were to take a look at my tangent, I would then be able to say it's going to be my opposite over my adjacent, which would be 6 over 8, which would be 0.75 that I would have for my tangent. All of these, provided that I know that this is my sine or my cosine, would allow me to extract and figure out my triangle off of, any other values given from these. We'll do a bunch of that later on. What I do want to note about this is that there is going to be a description of our triangle. Once you get familiar with these numbers, you can start to recognize triangles by the fact that they're going to go and have a sine versus a cosine. What I mean is this over here. If I take a look at a very, very low triangle, right over here, okay, we're going to start with this as being a super small triangle like that. If I'm going to be standing over here, what I'm going to see happening is my sine, which is a measurement of my opposite over top of my hypotenuse. I'm going to go and see the ratio of my sine as this triangle will get larger and larger and larger like that. What I would see is that my sine is going to go and increase as well. That ratio will go and increase. What I'm also going to go and see is if I were to go and deal with the cosine on this same angle over here, if the cosine is going to start out right now as being my adjacent over my hypotenuse, it's almost equal. So it's going to be like 0.99 or something like that at this point. But then as this gets taller, this triangle over here, my cosine would be dropping. My cosine is going to go and drop as, once again, my triangle gets taller and taller like that go through. You could put in a couple of values, and just verify this and see how that actual percent is going to get smaller and how the sine is going to go and get larger. But what it tells us is that when I'm looking at something like this, that is going to go and have a smaller value of sine than a value of cosine, that tells me that the cosine section is going to be greater, so it's going to be a flatter triangle. If the sine was going to be a larger value than the cosine, then it's going to go and tell me that it's a taller type of triangle. It'll just help you recognize triangles from where we are. Okay, they give you an exercise number 2, and they ask you to go and punch these in. Pause the video right now, punch those in, and then once you're done those, come back to the video. All right, you're back. That was magical. I hope you got the right answers that were in the back of your book. If not, try it again. Let's go and talk about getting trig functions from the angle. Now, the bottom of this page, the one that's right underneath over here, they talk about how to go and get trig functions from the angle. And then they go through, like here, press these buttons. These buttons are screwed because these buttons are not the buttons that we are going to go and have for our actual calculators that we are going to go and have. What they want us to do is they want us to go and find the sine of 8 degrees. Let's do it on our actual sharp, okay? Here's the sharp that you should be operating with. If you're not using this one, go get this one. It's going to save you in the long term. If you don't have this one physically yet, I am going to put up an emulator in your Blackboard shell. You should have seen that on the main content page. You can download, you can run this one. This one is running as the 506 TS because it's a European standard, but it's the same as our 520s that we have here in North America. And you can just use that one temporarily until you get yourself the actual one. You will not be able to use it on the exam, though. You need to make sure that you have either got the proper one or that you figured out how to use your own by the exam. Anyways, back to this. Let's go and find our sine of 8. You're going to hit clear a bunch of times just to make sure that thing is fully cleared out. If I take a look over here, I see I've got my sine, cosine, and tangent that are going to be available. And right above them, I see that I've got my inverse sine, my inverse cosine, my inverse tangent as well that are also going to go and be available. What I'll do to go find sine of 8 is I just punch in sine 8 and enter. That's literally all it takes off of this one. The book shows it backwards. They say press the 8 and then take the sine of it. We start by saying we're going to take the sine and then we say what the value is going to go and be. So my sine of 8 is going to be 0.139 that I'm going to go and have, which would tell you that it's a very small sine value, therefore it's got to be a very flat type of triangle, and the 8-degree triangle will be really flat. Let's try it again. We'll take sine of 30 degrees. When I take the sine of 30 degrees, I see that now I'm going to be at a 0.5. That's kind of a fun number as well. If I go to my sine of 45, we see that now it's gone up to 0.7. And so what we're seeing is that as my angle gets taller and taller, my sine is going to be going up. We'll try it with our cosine over here as well. Let's start with our cosine of 0.8. Cosine of 0.8 of 8 degrees. Cosine of 8 degrees is a 0.99. By the time we go to a cosine of 30 degrees, it's going to be at a 0.86, so we see it's dropping. And by the time we go to a cosine of 45 degrees, it's going to be at a 0.707, and we see that it's continuing to drop. You should note that the sine and the cosine actually are both the same once we get to that 45 degrees, and that would make sense because the adjacent and the opposite sides are going to be equivalent at that point. Once again, inside of your binder, there is a short little exercise. The point of this is just to get you familiar with these so that when we're talking about all the rest of the actual angles and usage in electrical, that you're going to be familiar with it and you're not struggling to find the keystrokes. So go out there, pause the video, do that quick little 6 question. All right, if we know what we have got for an angle, we can work that angle back into any sort of a triangle. Because we can go and figure out what we would have for adjacent or opposite sides off of this case, because we've got at least 2 values. That is the minimum amount we need for a right angle triangle is 2 values, and then we will be able to go and find all the rest of the values that we would need inside of that triangle. We'll burn through those really, really quickly. First thing that I want to note is that my sine of 20 degrees, sine of 20, is going to be equal to my opposite over top of my hypotenuse. Well, I see that my opposite is this A, so I'll just stick an A because it's unknown. But I do have a measurement for my hypotenuse, which is going to go and be 10. So I know that I've got an incomplete formula over here. I also know that my cosine of that angle, 20 degrees, is going to be equal to my adjacent, which would be B, I'll make it a small b, B over top of my hypotenuse, once again, 10. And so once I've got this, what I can do is I can punch in cosine, I can punch in sine, and I can cross those out, and I can go and put in the actual ratio value that these things would go and be. Let's try that really quickly. We'll take the sine of 20, so let's clear that, sine 20, which equals 0.342. Let's put ending after 3 decimal points, so I can go and cross this out and substitute 0.342 into it. And let's just quickly do the same with the cosine over there. Cosine of 20 degrees would be 0.939. Now this one would round up to become the 9 would roll over to become a 10, which would round us up to 0.94. So we'll put that one in as being 0.94. Remember, cosine is nothing more than a ratio of our 2 angles. So we got 0.94 and we got 0.342. What we can do then at this point is we can now cross-multiply out our formulas. If you are unfamiliar with how to go about cross-multiplication, I sent you guys back in December, I guess it would have been for this class that I'm talking to right now, But before your course started, I sent you a couple of modules on how to do some trades, math, and basic math. Make sure you go through those and are familiar with doing cross multiplication and formulaic manipulations. I'm going to do this formulaic manipulation. Basically, it's going to be me taking this 10 up to the other side. So I'll cross multiply it over here. I can do the same with this over here. And when I do that, it is going to go and tell me what my value would be, because I would be left with just a on this side over here. So we'll cross multiply the 10 up and over. And I'll cross multiply this 10 up and over as well, which tells me that for my B side, it's 10 times 0.94, which means that this would have to be 9.4. And for this one over here, it would have to be 3.42 over here, which is exactly what we would be looking for values off of that one. Using sine, using cosine, you're going to be able to go and solve for any of these values. The last one that we would have, if that one was 20 degrees over there, we could go and figure out that this one here would have to go and add up to be another 90 degrees, because we've got 180 inside of a triangle. So we would need to have an angle of 70 degrees over there. That's it. That triangle is completely solved. Sometimes we are not given the hypotenuse. When we're given the hypotenuse, it's really easy, because when we're doing the cross multiplication, we're always dealing with a bottom part, which is called the denominator, that we're carrying up to a top. Some cases, we're not given that. We're just given an angular value and one of the sides. And this is pretty common, where we're going to have an angular value and just the side alone. It's less commonly done like this. It's more commonly, to be honest, done where we're going to have that angle, and then we're going to go and have the hypotenuse. But yeah, whatever. Well, let's follow through what the book is doing here so that you can follow through on your own as well. What am I going to use for this? Well, I got a couple of different things that I can take a look at 40. A couple of them that are going to go and relate this side over here, my opposite side, because when I look at 40, I see that's a cross there. I can either go with my tangent of 40 degrees, or I can go with my sine, right? Opposite over top of hypotenuse. Sine of 40 degrees. If I do sine of 40 degrees, it would be my opposite, which would be 100, over top of my hypotenuse, which we don't have a value for, that would be b. And if I do my tangent of 40, it would be my opposite, 100, over top of my adjacent, a, which we don't have as well. Once again, we can go and take tan 40, sine 40, we can convert them down into decimals, and then we would be able to go and do that conversion. So let's just go and do that. Let's start with our tangent of 40. Tan 40 equals 0.839. So I know that I can go and substitute in a 0.839 into there. And then for my, oops, sorry, that's on the sine one there, 0.839 that I can go and substitute into that. And then for my sine 40 is 0.643 once we round that. 0.643. So I can substitute that 0.643 in for sine 40. That's what we're going to go and do. 0.643. Lovely. Same with this tan 40. We're going to substitute in that 0.839 over here. Okay. Now that we've got those inside, all we need to do is we need to go and isolate this term over here. The way to isolate would be to go and multiply a up to the top and then take that value, 0.839, down to the bottom. Same with this one over here. We're going to take b up to the top, and we're going to take the 0.643 down to the bottom. So I'll quickly go and do that. We will go and cross this one out, move this one down to become 0.839, and then we'll move that a up to this side. This one over here, we'll do the same thing. Move this to the bottom, 0.643, and then we'll move the b up to our top as well. And now we just got to go and take these values and divide them. If I take 100 divided by 0.843, gets me to a value of 118.62. So my A would have to be 118.62. And then if I do the same thing with my B, 100 divided by 0.643, 3 gets me to a value of 155.5. 155.5. Just looking at this triangle right now, you should be able to recognize that that looks like a pretty good triangle, right? We've got a hypotenuse that's longer than the other two. If my hypotenuse was shorter than one of the sides, we know we have a problem, but this looks good. If you want, you can just try and Pythagoras that thing through and see if it lines up. It will line up, but it's good practice still to work off some of that Pythagoras. Do I need to go and put this as a decimal over here? No, I do not need to go and put that in as a decimal. Really, if I want, I can put that in as the actual value, right? That value over there was my tangent of 40. So if I want it, I could put this in as 1040. And it should come out to the exact same one. Once again, we're going to try it. 100. Oh, that's way too many. Hit delete there. Divided by, 1 second. 100 divided by my tangent of 40. I'm going to bracket this, right? When in doubt, bracket it out, okay? And I see that it's bringing me out to a value of 119.17. If I compare that to this, 119.17, I see that it's approximately the same. The reason that this one over here is smaller is because we worked off of a rounded value that we had. So if I go through, do things fully properly, use the actual mathematical operators inside there, I'm going to end up with a more accurate one. The only reason we went through and did these as ratios was just once again to go and prove the mathematical process, why and how it's actually operating on there. Okay, that is going to be as far as we're going to go through into this. You've got 3 more triangles that you can go and solve, and then a self-test as well that's going to go and ask you to go and solve a bunch of triangles as well. Go through all of those. Don't just cheese out and look at the answers and say, that's what I would have written, because guess what? If you don't do the actual writing, you will not get familiar and practice up with it, and then you're going to struggle with it on the exam. So go through, practice those, and then we're going to jump back into our learning task number 2.